Okay, so we're going to talk about two theorems today. One of them is the MVT theorem, and one of them is Rolle's. They are very similar, but have pretty much one basic distinction. Okay, so first we're going to talk about the MVT, which is short for the mean value theorem. Now, when I say mean, you should think of average, which should make you think of average rate of change, which should make you think of slope. Okay, so I'm going to look at the remark off to the side. It says the mean in the mean value theorem refers to the mean or the average rate of change of f on the interval a to b. Okay, so the average rate of change is the slope. That's the slope, not the derivative, not the tangent line, just the slope. So given 2 points, I'm going to do y minus y over x minus x, and I'm going to get the average rate of change between 2 points. Okay. Here's what the mean value theorem states. Number one, f has to be continuous on the closed interval a to b, and it has to be differentiable on the open interval a to b. If that's true, then there exists some c value so that the derivative of c, which is the slope of that tangent line, is equal to the average rate of change, or the slope, through the points A and B. So this is my interval, and my function, which is this guy, has to be continuous on the closed interval, differentiable on the open interval. Okay, so from here to here, got to be continuous, got to be differentiable. So continuous, and then no sharp turns and no vertical tangent lines. If that's the case, then if I can find the slope through those 2 points, the MVT guarantees a value C such that the tangent line at C is equal to or parallel to the slope between the 2 points A and B. So if I were to pick 2 different points, let's do A and B. So here's A, here's B. There's this part. So what it does is it guarantees, and I'm eyeballing this, and C is not in the middle. It just has to be in between the two. So, oh no, that's too, see, that wouldn't work because that tangent line slope would be too steep. It's got to be parallel. They got to be equal. So more down here. So that the slope of the tangent line at C is equal to the slope of the, it's called the secant line because it goes through 2 points, or just your average rate of change. So the goal is to find that C where that happens. Sometimes they'll give you the C and want to know what the slope is. Okay, so verbally this says the instantaneous rate of change, that's the derivative, equals the average rate of change. So your MVT finds where your AROC equals your IROC. Your AROC is through some interval A to B, and your IROC is at some point C, but it finds where they're equal. Graphically, it says that the tangent line is parallel to the secant line. All right, let's look at the AP tip. Be able to apply the MVT theorem on the AP exam. It may be referred to directly, like by name, or it may just be necessary to use the MVT to justify your answer. So they may not come out and say, hey, you need to use this theorem. You just need to know that that's what you're using. So this slide right here is really, really important, not just to understand what the MVT, the process of the MVT, but the point of the MVT. And it is where your instantaneous rate of change, the slope of the derivative, equals the average rate of change, your AROC, which is just your mean, your average rate of change through 2 points. Okay, so let's practice. Consider the graph of the function. Okay, so the first thing I notice is that it's quadratic. He has no issues. He's continuous everywhere. He has no sharp turns and no vertical tangent lines. I have to state that. Okay, so I'm going to say f of x is continuous on the interval closed 2 to 4. F of x is differentiable on the open interval 2 to 4. So that is the gatekeeper for the MVT. So we've passed the bouncer. Okay, we're in. It says use the MVT to determine a point C. Okay, so guys, C is an X value. I'm looking for an X value that should be in between the -2 and the 4 X values, such that the tangent line at C is parallel to the secant line. Okay, so the first thing I need to do, guys, is I need to find my secant line. I know you want to jump in and take the derivative, but I need to find the AROC first. So I have my two x's. They are -2 and 4. I need to find my two y's. So I'm going to do f of 4 and f of -2. I don't know why I do the 4 first. I just do. Let's see. So that's 16 minus 4 minus 12. So that's a 0. And plug in a -2. That would be 4 plus 2 minus 12. 6 minus 12. That's a -6. So I have my x values and I have my y values. So now I'm going to find my slope. So I'm still under AROC. So my slope is going to be y minus y over x minus x. Or you could have done y minus y over x minus x. Either way, you get the same answer. That's going to be 6 over 6, which is 1. That's going to be -6 over -6, which is 1. Just to show you both ways. So my AROC equals 1. AROC is the average rate of change. It is the slope of the secant line. It is your slope. It is the average rate of change. Okay. So now I know what my goal is. My goal is to find the C value such that the slope of the tangent line at C is parallel to the slope of the secant line through the points through the x values -2, 4. Well, I know that the slope through the points, the x values -2, 4 is a 1. So now to find my IROC, I'm going to take the derivative of f of x, because that finds me the slope of the tangent line at any given point, and that's 2x minus 1. Now, I want 2x minus 1 to equal 1 because parallel slopes are equal. And I want my IROC to be parallel to my AROC, or to be equal. So 2x minus 1 equals 1. Well, then I just solve this. Add 1, divide by 2, I get x equals 1. That is the C value. Now, double check. Is he in this interval? Yes, he is. So I can keep him. If he wasn't in that interval, then you would say that there does not exist a C in that interval that the MVT applies. So the answer here is 1. Just make sure that you go and check, make sure he's in that interval. Okay. Determine if the MVT can be applied to F on the closed interval A to B. If it can, find all values of C. Okay, that makes it sound like there's potentially more than one. on the open interval a to b such that f prime of c equals f of b minus f of a over b minus a. Okay, so this is IROC equals AROC. And my function is this thing. All right. He has issues. Where does he have issues? See, number one didn't have issues. He's quadratic. It's very well behaved. This guy has an asymptote at x equals 0. Okay, so he's not continuous. But I'm only interested on the interval 1 to 4. So he is continuous on the closed interval 1 to 4 by the skin of his teeth. And he is differentiable on the open interval 1 to 4 because I know he doesn't have any sharp turns. The reason I know that is because sharp turns come from absolute values. And I know he doesn't have any cusps. And we're going to do enough cusps where you can see those come from like x to the 2/3 kind of a functions. And they'll pop up here in a little bit and you'll get the hang of those. I've got this lovely graph off to the side that shows what this graph looks like in the interval 1 to 4. You can kind of see it's headed south towards the asymptote, the vertical asymptote at x equals 0. They were super nice and gave me my points. If they had not done that to find my AROC, I would have found f of 1 and f of 4. 4 over 1 is 4, and 5 minus 4 is 1, and 4 over 4 is 1, and 5 minus 1 is 4. So, yes, I agree. So then to find the slope, and I'm going to label him M, I'm going to have correct notation. So I'm going to do 4 minus 1 over 4 minus 1, which gives me 3 over 3, which is 1. So the slope, the average rate of change is a 1. So now what I want to do is I need to take the derivative because I need to find the IROC. So f of x, I'm just going to prep him for the negative 1. Okay, so now f prime of x on 4x to the negative 2. And I want to set that equal to the AROC. So 4 over x squared equals 1. I'm going to multiply both sides by x squared. I'm going to root both sides. I'm going to get plus or minus 2. Now, I'm in the interval 1 to 4. So I only get to keep the 2. And that is your C value. And you could write C equals 2 if you want to, or you can write x equals 2 and box it in. It's all good. Okay, number 3. Okay, again, he has issues. He has issues at 0. And quite frankly, it doesn't matter that it's a hole or an asymptote. This one's going to be an asymptote. But he has an issue at 0 because a hole or an asymptote are neither continuous. So that would be all bets are off, regardless of which one it is. So he has an asymptote at 0. 0 is not in my interval. If this was an FRQ, I would probably state that, just like I did in the last problem. I would probably state asymptote at x equals 0, not in interval, and then put a check mark. So we're all good. So I know that I am continuous, that you have to write this. Continuous on the closed interval 1 to 4, differentiable on the open interval 1 to 4. Usually these are FRQs. And the point values, the stating the conditions, usually gets you a point. Just stating the conditions. Okay, tell you what, press pause, go find your AROC, then take the derivative, and see what you can do from there. And then hit play when you're done. All right, so AROC f of 1 is going to be 5. F of 4, 8 over 4, which is 2. So 5 minus 2 over 1 minus 4, which is 3 over negative 3, which is negative 1. So far, slopes have been very nice. But trig is coming, don't you worry. So let's see. I'm going to prep him a little bit because I don't want to do the product rule. I mean the quotient rule. I know he's over a single term, so I'm going to pull it apart and make that 1 plus, that'd be 4 over x. So 4x to the negative 1. So this is what I did, guys. Pulled it apart and then cleaned it up. So I just prepped him. Now make sure when you do that that you're still writing f of x. Make sure your notation is correct. Now I'm going to take the derivative. So then I have 4, and I want that to equal a negative 1. Multiply both sides by x squared. Divide by negative 1. Root both sides. And I'm in the interval 1 to 4. So there he is. Okay, all right, finally, here we go, sharp turn. So you have to know that the absolute value is a V and it has a sharp turn. You also have to remember your shifts because odds are this one would be without a calculator. This would probably be multiple choice without a calculator. I know that I'm going to shift him right 2/3. So I know that's what he looks like. I'm on the interval 0 to 2. So from here to here. And he has a sharp turn in there. So I can't use the MVT. So here's what I'm going to say. I'm going to say he is continuous on the closed interval 0 to 2. But I'm going to state that he is not differentiable on the open interval 0 to 2. Therefore, MVT does not apply. Cool. Number 5. Now, number 5 has issues because he's a shooting star. So let's see if we can figure out what his graph looks like. 3 minus x. So he's going right 3. It's a negative inside the function. So that's inside the house, so that's a twirl. So he looks like that. I am going on the interval from -1 to 3. Okay, so we are continuous on the closed interval -1 to 3, and we are differentiable on the open interval -1 to 3. Just barely, but we are. Okay, so now that we've done that, I tell you what, pause it, go find the A rock, go take your derivative and see what you can do with this one. All right, I got a slope of a -1/2. So let's see. There's the turkey. There's the duck. A little cleaning. Yeah. All right, so now I'm going to take that and set them equal to that. I'm going to cross multiply because I'm over an equals. So -2 equals -2 root 3 minus x. I'm going to divide by -2. I'm going to square both sides. I'm going to subtract the 3. I'm going to divide by -1. Is that in my interval? Yes, it is. So I'm finding the x value so that the slope of the tangent line equals the slope through the endpoints of this interval, where the I-rock equals the A-rock. All right, and then yay, trig. The nice thing about cosine and sine, they are very well-behaved functions. You get into tangent and cotangent, they have issues. But cosine and sine are just nice and flowy and curvy and no sharp turns and no vertical tangent lines and continuous everywhere. So yay. Okay, so I have to state that. Continuous, closed, differentiable, open. A-rock. F of pi over 2. Cosine of pi over 2 is the x value. That's a 0. X value. That's a 0. Huh. So if I go find my slope, y minus y over x minus x, which is 0 over, I don't care, because 0 over something is 0. So the slope is 0. Okay, so we are top or bottom of a hump. So I'm now going to go find the I-rock, which involves the derivative cosine, which is negative sine. So now I'm going to set negative sine of x equal to my A-rock. I'm going to divide by -1. Now, I want to know where sine is 0. Well, sine is 0 at a bunch of places. So remember, you're in this interval. Okay, so let's think unit circle. So we're going from pi over 2 to 3 pi over 2. So I'm talking about that half of the circle. So sine is the y value, and the y value would be 0 there, which is pi. And pi is in that interval because that's half a pi, and that's 1.5 pi's. So pi is in there. Love some trig. Okay, number 7. This is the last one for the MVT. Sine of 2x, very cool, and 2x, linear, very cool. So 2 very cool functions, no issues. So first I'm going to find the A-rock. So let's see. Oh, no, I'm not. That's not at all what I'm going to do first. First, I'm going to state that we are continuous and differentiable. Continuous on the closed interval, differentiable on the open interval. Now I'm going to find my A-rock. So I need f of 0 and f of pi. Feel free to pause this, go at your own pace, and then come back and check it. So let's see, sine of 0, y value, that's 0, plus 2 times 0, sine of 2 pi, it's all the way around, y value is 0, 2 times pi is 2 pi, so then y minus y over x minus x. So negative 2 pi over negative pi, which is 2. So there's my m. Good notation. So now I'm going to go find f prime. This is a turduck, so sine goes to cosine of 2x times 2. So 2 cosine 2x plus 2. And I'm going to take that and set it equal to my slope, which is a 2. I'm going to subtract the 2, divide by 2. Now I'm going to solve it. So I'm going to find where is cosine 0, and I'm going to set 2x equal to those places. Now, cosine is 0 lots of places, but I only want to be on the interval from 0 to pi. Cosine is the x value, and x is going to be 0 up here at pi over 2. So that happens at pi over 2. Yeah, that happens at pi over 2. Okay, then I'm going to divide by 2, and I'm going to get pi over 4, which is in my interval. All right, here's the fun part. I need him to be in my interval because he is my C value. And pi over 4 is in my interval. But what I did was I chose pi over 2 because pi over 2 is the only place on the unit circle where cosine equals 0 that's in my interval. But I don't need this to necessarily be in my interval. I need that to be in my interval. So what if we picked this guy also? Because down here at 3 pi over 2, cosine is 0. So if I included him and then I divided by 2, that would give me 3 pi over 4, which is still in my interval 0 to pi. So this guy has 2 answers. Okay, so let's chew on that for just a second. To find where cosine equals 0, if I still have to divide by 2, then I need to think a little bit beyond just the interval that I see because I still have to divide my answer by 2. So that's why I didn't just include the pi over 2. I went ahead and got the 3 pi over 2 because then when I divide both of those by 2, I get pi over 4 and 3 pi over 4, which are both in my interval. I know I don't need to keep going because 3 pi over 4 is just inside my interval. And I can tell pi over 4 is here, 3 pi over 4 is here, the next one would be here, and that would be past my interval from 0 to pi. So, star that. If we need to talk about that more in class, feel free to bring that up, and we can discuss that. All right. Now let's talk about rolls. Now rolls is kind of like a cousin to the MVT, but there is a difference. Rolls is very particular, very picky. So we'll say that MVT and rolls are related. So if we go to a family reunion and you've got that one cousin who, when everybody brings potluck, they can't find anything that they want to eat. They don't like any of the food. They just want chicken nuggets. I don't know. Rolls is kind of like that person. Super, super, super picky. Like almost kind of stingy. Like when you look at them, it's like, ugh, come on, eat a biscuit. So here we go. Rolle's theorem. Let f be continuous on the closed interval and differentiable on the open interval. Okay, that's exactly the same. No big deal. So we have to do continuous and differentiable. Okay, now here's where it gets different. F of A and F of B. Now F of A and F of B are the y values for A and B. And it's saying that they have to be equal. Well, guys, if F of A and F of B are equal, then won't that make this a horizontal line? And if that's a horizontal line, won't his slope always be 0? So Rolle says, all right, I got you MVT, but I'm going to be picky. I don't want any secant line. I want the secant line that's horizontal, and that's the only secant line I want. Okay, so here's how I remember it. Rolle's has an O in it, and they want the slope to be 0. The reason why is Rolle says, all right, your Y values of your 2 points have to be equal. That's going to line them up and make the secant line be a horizontal line. Because think about it, if I find the slope and I do y minus y over x minus x, and these two y values are equal, you're going to get a 0 on the top, which means your slope is going to be a 0. So then Rolls comes in and says, okay, so now that we've established that we are a horizontal line, there exists at least one number c in this interval where the derivative equals 0. Okay, the derivative is the slope of the tangent line at any given point. So what you're saying is the slope of the tangent line is also 0. Okay, that's fine. That's fine. Rolls wants to be picky. We can be picky, but let's think about what this tells us. If the slope of the tangent line is 0, that means it has to be the top or the bottom of a hump, which means it has to find maxes or mins. So Rolle's theorem, while very picky and stingy, is very powerful because it finds tops and bottoms of humps, because that's where the tangent line's slope equals 0. So what is the difference in the conditions between the mean and the and Rolle's? The conditions, differentiable, continuous, same. The other condition for Rolle's is that f of A has to equal f of B. That is not true in the MVT. But for Rolle's, those two things have to be equal because that's what's going to make your y's the same, which is what's going to make your slope 0. Okay? What does Rolle's theorem tell you must exist on a given interval? A max or a min. Top and the bottom of a hump. If I have a tangent line whose slope is 0, that has to happen at a hump. Therefore, it is a max or a min. A relative max or a min must happen at those 2 points. Okay? And that's it. That's Rolle's. It's a cousin of MVT, and it's just super picky, but kind of powerful. Okay, find the two x-intercepts of that quadratic and show that f prime equals 0 at some point between the two x-intercepts. Okay, so here's our graph. These are the two x-intercepts. They've already found them for us. So I'm looking for this x value, this 3 over 2. That's the goal of what we're trying to find. Okay, so let's go find it without the aid of the graph. Okay, so first you have to say continuous closed between the two x-intercepts. Okay, so I guess I have to find the intercepts first because I don't have an interval. So let's solve this guy, because that's how you find x-intercepts. So I got 2 and 1. So continuous on the interval from 2 to 1, differentiable on the open 2 to 1. Okay. Now I need to prove that f of 2 equals f of 1. So f of 2 is 4 minus 6 plus 2. That's a 0. And f of 1 is 1 minus 3 plus 2, and that's a 0. So I have just proven that. Those are the 3 conditions for Rolle's. just like the MVT, just adds that extra 1. So I know that my slope is 0. So now what I'm going to do is I'm going to take the derivative and I'm going to set it equal to 0, because again, that's the slope through those 2 points. This is the slope through these 2 points, m equals 0. So my goal is to find that 3 over 2. And if you solve this, you see that you get 3 over 2. So I know that the vertex of that parabola is at x equals 3 over 2. 3 over 2 is the x value for which the slope of the tangent line is 0. Find all values of c in the given interval such that f prime of x equals 0. Find all the values. Okay, so here we go. We are continuous. He's a degree 4, so yeah. Continuous on the closed, differentiable on the open, and I need to find f of negative 2 and f of 2 and show that they're equal. Negative 2 to the 4th, 4, 8, 16. 2 squared is 4 times 2 is 8. And then a positive 2 is going to be the same thing because those are even powers. So I just proved that f of negative 2 equals f of 2. Therefore, I know Rolle's applies. So now I'm going to take the derivative, 4x cubed minus 4x, and set it equal to 0, because that's my slope. Let's see. I'm going to GCF of 4x. So that one's going to give me x equals 0, and that one's going to give me x equals plus or minus 1. Dang, he's got 3. Okay, so now let's go look at his graph. Yep, he does. He has 3. On the interval negative 2 to 2, he has 3 x values where the slope of the tangent line equals 0. So he has 3 x values that occur at humps. One of them is a max, and 2 of them are mins. Oh my. Okay, number 3. He's a cubic function, very well behaved, very continuous. So let's state that. Let's say f of x is continuous, closed, differentiable, open. Okay, now let's go find f of negative 1 and f of 2. Again, feel free to pause this, go out on your own, come back and check it. If I plug a negative 1 in, let's see, that would be a negative 4. That would be a 0. That would be a negative 3. If I plug a 2 in, negative 1, 3, and a 0. So f of negative 1 equals f of 2, which is one of my conditions, my third condition for rolls. So because of that, I know my slope is 0. It's kind of like doing this extra step shows you that the slope is 0, so you don't have to go find the slope. Whereas in MVT, you don't have to show this step, but you have to do this part because you have to get the y values because you have to go find the slope because you don't know what the slope is. For rolls, the slope is 0. So I got to take the derivative of this thing. I could do kind of a 3-way version of the product rule, like a leave it, derivative, plus leave it, derivative, leave it, plus derivative, leave it, leave it. I'm just going to multiply. It's just cubic. That's not awful. X minus 3. All right, let's see. X squared minus X minus 2. And then so this is the kind of math, this crunchy algebra math, that you need to be sharp and crisp and quickly efficient. You don't need to back away from multiplying three things together like that. Um, and it doesn't need to take you 5 minutes either. Like, it needs to be quick, accurate, efficient. So this is my f of x. So my derivative, and then I take that and I set him equal to 0. This bad boy does not factor because I'm going to have a 3 and a 1 and a 1 and a 1, and there's no way I'm going to get an 8 out of that. It is a hideous complete the square, so I'm pulling out the big guns, and I'm going quadratic formula. Opposite of b squared minus 4ac all over 2a. That would be 64 minus 12, so 52. If this was an FRQ, you could stop here, but I mean, you need to check, and I'm going to bet one of these is not in our interval. We're from -1 to 2. 52 is 4 times 13. So I'm going to clean this up just a hair. Then I'm going to let everybody cheat with a 2. Okay. So I have to figure out if 4 plus root 13 over 3 and then 4 minus root 13 over 3 is in my interval. So I'm going to grab my calculator and I'm going to type it in, which I want you to do. So you're going to do 4 plus root 13, hit enter, and then divide it by 3. Just make sure the whole thing gets divided by 3. And then do the other one. And I got 2.53 and a 0.131. And the 2.53 overshoots my interval because my interval is from -1 to 2. So I can't keep him, so I can only keep the -1. There we go. All right, absolute value. Got a little sharp turn action going on here. Let's see. Where is my sharp turn? This would go, all right, so if you need to look at this a little bit more normal, I know that he's going to go up 4, which does not affect me. I know he's going to go left 2. Left 2 puts the sharp turn at -2. Nope, in that interval. We are continuous from -3 to -1. We are not differentiable from -3 to -1. So Rolle's theorem does not apply. Yay. Okay, this bad boy's got issues. Let's see. He has issues. Looks like he's got issues at ±1. Oh, they're both in my interval. So he is not continuous. And then I'm going to put asymptote at x equals ±1 just because I'm communicating with them that I know that. So Rolle's theorem does not apply. Well, sweet. That picks the pace up a little bit. Okay, he has issues. He has issues the bottom at x equals -4. And I don't care if it's a whole or an asymptote. Like, go factor the top, that's fine. I don't care. The point is, he's not continuous at -4, but -4 is not in my interval. So all systems go. So he is continuous on the closed, and he is differentiable on the open. And now I need to prove that f of -1 equals f of 5. So f of -1. All right, here we go. 1 plus 4 minus 5 over 3, 0. 25 minus 20 minus, oh, that was bad, minus 5 over 9. That's a 0. Now, just make sure you guys understand, these values don't have to be 0. They just have to be the same. Because then when I do my slope, my y minus y, I'm going to get a 0 on the top, which makes the slope 0. But anyway, those two are good, and I just proved that. They are the same. I was just saying that they don't have to both be 0. Oh no, now I got to low D high this bad boy. Oh, okay, right small. Low D high, feel free to pause it and do your own thing. Minus high D low over low, low. Let me check myself. Yep. All right. So there he is. There's your derivative. And I'm going to set him equal to 0 because that is the slope. When I do that, and you guys notice I did not lobster the bottom because I knew what was going to happen. When you do rolls, your slope is always going to be a 0. So I'm setting it equal to 0. So when I multiply both sides by what's in the bottom, which is what I do to solve it when it has a fraction, I'm going to get this, and then 0 times that's just going to give me 0. The bottom's just going to go away when it's set equal to 0, only when it's set equal to 0. This does not factor. There are no factors of 11 that will somehow give me an 8. However, this is a lovely complete the square. All right. So, hi, Grandpa. I'm going to move you over there. Change the sign because he crossed the equals. Half of 8 is 4, squared is 16. Add 16. I'm going to the other side of the equation, so I also add 16 because what you do to one side, you do to the other. And this becomes x plus 4 squared equals 27. Square root both sides. 27 has a square in it. It's 9 times 3, so 3 root 3. And subtract my 4. Oh, that is beautiful. Love some complete the square. Okay. But I don't know if I get to keep both of them. So I need to go to my calculator and I need to type in -4 plus 3 root 3 and get a decimal. I need to do -4 minus 3 root 3 and get a decimal. My interval is from -1 to 5. My decimals, I got 1.196 and I got a -9.196. Obviously, I can't keep him. So -4 plus 3 root 3 is the one I get to keep. All right, home stretch. Okay, this one's super straightforward. So you pause it, you do it. He's quadratic, so he's super friendly Continuous, absolutely differentiable. Heck yeah. Now I need to prove that f of negative 3 equals f of 1. So f of negative 3 is 9 minus 6 minus 3, 0. And f of 1, 1 plus 2 minus 3. Okay, so just prove that. Awesome. Therefore, I know my slope is 0. So now I'm going to do the derivative and set him equal to 0 and divide and make sure he's in my interval, which he is. So I get to keep him. Yay. Okay, so here's how you can see the MVT or rolls in action. So here we go. 2 stationary patrol cars equipped with radar are 5 miles apart on a highway. As a truck passes the first patrol car, its speed is clocked at 55 miles per hour. 4 minutes later, when the truck passes the second patrol car, its speed is clocked at 50 miles per hour. Prove that the truck must have exceeded the speed limit of 55 miles per hour sometime during those 4 minutes. Okay, now your instantaneous speed is your IROC. And that's what we're trying to prove, that at some point he hit above 55 miles an hour. Okay. What I need to do is find the average rate of change from point A to point B. So I'm looking for the average speed from, let's see, 5 miles apart, 4 minutes later. Okay, so we'll call point A 0 as far as time goes, and we're going to call point B 4 minutes later. That's a 15th. Yeah, 15 times 4 is 60. So 4 minutes out of 60 minutes. All right, so okay, time out. Speed is in miles per hour. So I can't do this. I can't do 0 minutes in 4 minutes, but then put 55 miles per hour and 50 miles an hour. So at 0, I know he was going 55 miles per hour. And at 4 minutes, I know he was going 50 miles per hour. So this is time, and this is speed. Time, speed. The problem is I can't have the 4 because the 4 is in minutes, and the 50 and the 55 are in miles per hour. So I have to change the 4 into hours. Well, 4 minutes out of 60 minutes in an hour reduces to 1/15. Okay, so I'm going to replace the 4 with a 1/15. Now we are all in the same units of measurement. So now what I'm going to do is I'm going to find his AROC. I'm going to find the average rate of change between these two. So 55 minus 50 over 0 minus 1/15, which is 5 over negative 1/15. And then if you Bojangles that, I get negative 75. Okay, now you're done with the math. Now you have to make the connection. His AROC at some point, his average rate of change is 75 miles per hour. The MVT says that there must exist an instantaneous speed during the interval 0 to 15 where his IROC equals his AROC. So where his instantaneous rate of speed has to equal 75 miles per hour. Therefore, the truck must have gone 75 miles per hour at some point during those 4 minutes. Okay, I'm going to say that again. You write what you want to write. The MVT, now this is MVT, not rolls. Like, we're not saying, if we're talking rolls, we would say that his speed didn't change. Okay, MVT says that there must exist an instantaneous rate of change on the interval 0 to 1/15, where the speed equals 75 miles per hour. Therefore, the truck must have gone 75 miles per hour at some point during those 4 minutes. I don't know when. I'm not trying to find the when. I'm just trying to prove that it exists. And an MVT will not only find it, but it'll also state its existence. Okay, so we've just answered this question, but let me just do this extra little nugget. If he reached 75 miles per hour, does that also prove that he hit 70 miles an hour? Absolutely, because of continuity. If I reach, that's the IVT, if I've reached 75 miles per hour, then at some point I hit 70 miles per hour. And if I started at 55 and ended at 50, I had to hit 70 miles per hour twice. Once on the way up to 75 miles an hour and once on the way back down. If I started at 55 and I ended at 50, and at some point I hit 75, I had to hit 70 twice. I had to hit 60 twice. I had to hit 56 twice. So those are the kinds of application questions that I can ask you. And we'll practice more of those.